Do you enjoy eating dates? Have you ever wondered where they come from, or how they are grown and harvested? Today, we're taking you to Rajhi Date Farm, located in the Al Qassim region of Saudi Arabia. It holds the Guinness World Record as the largest date palm farm in the world, covering approximately 5,400 hectares and home to more than 200,000 mature date palms. This enormous plantation produces thousands of tons of dates every year, generates tens of millions of dollars in annual revenue, and supports a vast supply chain that provides livelihoods for thousands of workers. What's even more remarkable is where this farm is located. The entire plantation lies deep in the Arabian desert, where summer temperatures regularly exceed 50 degrees Celsius. Annual rainfall is less than 100 millimeters, and the sandy soil retains very little moisture. Most fruit trees would struggle to survive under these conditions. So how has Rajhi transformed one of the harshest environments on Earth into one of the world's most productive date plantations? Let's find out. The true engine of the Rajhi Date Farm lies hundreds of meters below the boiling sand. Traditional agriculture relies on shallow wells digging down maybe 20 to 50 meters to find surface groundwater. In the Al Qassim region, that traditional method hits nothing but solid dry bedrock. Heavy industrial drilling rigs were brought in to penetrate up to 1,000 meters deep to tap into the Saq Aquifer. This is not a standard replenishing water table. The Saq Aquifer is a colossal subterranean reservoir of fossil water trapped beneath the earth since the last ice age over 10,000 years ago. It is a strictly non-renewable resource. However, it holds thousands of cubic kilometers of water, providing the massive and consistent hydraulic pressure required to sustain an industrial operation covering more than 5,000 hectares. Pumping millions of gallons of ancient water into the desert air using traditional flood irrigation would be a massive financial waste. Standard center pivot irrigation sprays water into the air, losing up to 60% of its volume to wind and immediate evaporation before it even touches the roots. To maximize efficiency, the water at Rajhi is immediately routed into a highly pressurized closed-loop drip irrigation network. This massive grid of subterranean and surface piping delivers water directly to the base of each individual tree at a precise rate of 150 liters per tree per day. The system is entirely automated and integrated with real-time moisture sensors buried 50 centimeters deep in the root zone. The central control unit mixes exact chemical ratios of nitrogen, phosphorus, and potassium directly into the water stream. This technique, known as fertigation, ensures that every single drop of water carrying precise chemical nutrients is injected straight into the active root mass. By delivering liquid nourishment directly into the subsurface sand, they cut the surface evaporation rate down to absolute zero and increase fertilizer uptake efficiency by 40% compared to standard tractor broadcasting. Now we have a perfectly engineered water delivery system, but applying this water to standard seeds would trigger a biological disaster. If you plant 200,000 traditional date seeds, you leave your entire supply chain to the mercy of natural genetics. Natural germination yields a 50% rate of male trees. Male trees consume the exact same amount of water and fertilizer but produce zero fruit. That is an immediate 50% loss on your initial investment. Furthermore, even the female trees grown from seeds will suffer from extreme genetic variation. You would spend 7 years feeding a tree only to discover it produces small, low-quality dates. In a high-stakes industrial operation, predictability is everything. To eliminate genetic risk, the engineers turned to advanced tissue culture technology. Not a single tree at this facility was grown from a seed. Agricultural scientists extracted cellular material from one single highly productive female date palm and multiplied it inside a sterile laboratory environment. The result is an army of 200,000 perfect biological clones. Every single tree on the farm is a guaranteed female. Every tree shares the exact same genetic code, and every tree processes water and nutrients with identical mechanical efficiency. While a traditional wild date palm might yield 40 to 60 kilograms of fruit per year, these genetically identical clones are engineered to push out 100 to 150 kilograms of premium export-grade fruit every single harvest. These cloned palms require about 5 to 7 years of intense care to reach maturity. Once fully grown, they function as relentless biological water pumps. They are highly tolerant to the scorching heat and the slightly brackish nature of the fossil water. Traditional crops like wheat or corn begin to die when water salinity reaches 1,000 parts per million. The date palms here easily filter and process water with salinity levels pushing 3,000 parts per million, extracting the fresh water they need and isolating the salts. But nature still presents a massive hurdle. Relying on desert winds or insects to pollinate a forest of this scale is a massive financial risk. A poor pollination season means millions of dollars in lost revenue. Traditional farms hire workers to climb 15-meter-high trunks to hand-pollinate each flower, which is slow, dangerous, and yields only a 60% success rate. Therefore, the engineers completely removed nature and manual labor from the reproductive equation. During the flowering season, workers utilize heavy mechanization to pollinate the trees. They deploy high-pressure air compressors mounted on specialized tractors to shoot a precise mist of male pollen directly into the core of the female flowers. This forced mechanical intervention guarantees a 100% pollination success rate across the entire farming grid in a fraction of the time. Once the fruit bunches begin to develop, workers execute a strict thinning process. They physically strip away up to 30% of the excess dates. This forces the tree to pump more biological energy into the remaining fruit, doubling their final size and sugar content. The targeted bunches are then wrapped in specialized mesh bags. This physical barrier serves two critical functions. It prevents birds and insect swarms from destroying the crop while also acting as a thermal shield to prevent the dates from cooking in the direct sunlight. Solving the water and pollination problems created a completely new and highly profitable opportunity. The sheer physical mass of 200,000 towering date palms creates an artificial microclimate in the middle of a dead zone. The massive upper canopy acts as a biological heat shield, blocking out severe solar radiation. Out in the open desert, the bare sand reflects heat, pushing ground temperatures past 50 degrees Celsius. Underneath this dense canopy, the ambient surface temperature drops by 10 to 15 degrees Celsius. The engineers capitalized on this thermal drop immediately. The artificial shade allows them to establish a secondary agricultural layer on the desert floor. Instead of leaving the ground bare, they intercrop the rows with alfalfa and introduce controlled flocks of sheep. Traditional weed control requires expensive chemical herbicides that damage the soil profile and cost millions of dollars annually. Here, the sheep act as a biological maintenance crew, grazing on weeds and keeping the farm clean at zero operational cost. As they move, their waste drops directly onto the soil, completing a natural nitrogen cycle. The date palms provide the critical shade required for the sheep to survive the desert summer, and in return the sheep provide hundreds of tons of organic fertilizer back to the date palms. It is a highly optimized closed-loop biological engine running at maximum efficiency right in the middle of a barren wasteland. The biological engine operating in the desert requires an equally powerful industrial supply chain. When 200,000 date palms reach peak maturity simultaneously, traditional hand-picking is completely obsolete. The scale of the Rajhi Date Farm demands heavy mechanization. During the intense harvest, window temperatures still hover around 40 degrees Celsius. To prevent the crop from spoiling on the branch, fleets of hydraulic cherry pickers are deployed across the 5,000-hectare grid. These machines elevate workers 15 meters into the canopy, allowing them to cut the 20-kilogram fruit bunches efficiently. The operation runs 24 hours a day, yielding over 10,000 metric tons of raw dates in a single season. Getting the fruit off the tree is just the first phase. The raw dates are immediately transported to a highly automated processing facility. Manual sorting is too slow for 10,000 tons of biomass. Instead, the dates are fed onto high-speed conveyor belts passing under advanced optical sorting machines capable of processing 5 tons per hour. Laser scanners analyze every individual date, calculating its exact size, color, and moisture content in a fraction of a millisecond. The machinery automatically separates the premium export-grade dates from the rest. Absolutely zero biological mass is wasted. Dates that do not meet the strict visual requirements are diverted into a secondary industrial line. Heavy presses crush these irregular dates to extract high-value date syrup and thick date paste, which is sold in bulk to the global baking industry. The extreme desert environment actually plays a critical role in the final quality of the product. The biological stress placed on the trees forces a unique chemical reaction. The massive temperature variations between the 50-degree daytime peaks and the 15-degree desert nights combined with the strictly controlled drip irrigation forces the date palms to pack the developing fruit with concentrated natural fructose. The flesh becomes thick and exceptionally dense. A single premium date from this farm contains up to 70% natural sugar by weight and carries 3 times the potassium of a standard banana. It functions as a highly efficient calorie and mineral delivery vehicle, outperforming almost any other cultivated fruit in terms of raw nutritional density. This precise biological engineering translates directly into massive financial returns. The target market is huge. Premium dates can command wholesale prices of up to $15 per kilogram on the international market. By shipping these high-end products to retail markets across Europe, Asia, and North America, the farm consistently generates tens of millions of dollars in annual revenue. Traditional agricultural projects in arid zones often spend up to 40% of their budget on water acquisition and weed management. By utilizing highly efficient drip systems and biological weed control, Rajhi keeps overhead costs incredibly low, maximizing the profit margin on every ton sold. Because the entire operation is built on cloned tissue culture, buyers know that every single shipping container will meet exact specifications with zero genetic variation. This level of industrial predictability guarantees premium pricing. But the return on investment extends far beyond the farm itself. By forcing this barren land into high-yield production, the engineers triggered a massive economic chain reaction. The operation supports a fleet of transport trucks, massive climate-controlled storage warehouses, and advanced packaging manufacturing facilities. They took a stretch of dead sand and engineered it into the anchor point of a massive regional economy, proving that with enough mechanical leverage, even the harshest environments can generate immense agricultural wealth. However, the engineering triumph of the Rajhi Date Farm conceals a brutal geological reality. This entire system relies on draining the Saq Aquifer. Unlike standard groundwater that recharges through seasonal precipitation, fossil water is a strictly finite resource. Pumping millions of gallons at an industrial rate means this subterranean reservoir is slowly emptying. If this extraction velocity continues, the aquifer could face severe depletion within the next few decades. When you remove massive volumes of water from deep sandstone layers, the physical structure of the earth compresses. This leaves the region vulnerable to severe land subsidence and irreversible localized salinization. To understand the scale of this threat, we only need to look at the Central Valley of California in the United States. American farmers also relied heavily on deep groundwater pumping to sustain massive agricultural zones. The result was catastrophic. The ground surface in California has literally sunk by several meters in some areas, permanently destroying the physical capacity of the aquifer and leaving thousands of domestic shallow wells completely dry. The Saudi operation faces the exact same mathematical equation. It is a calculated trade-off between short-term agricultural dominance and long-term geological stability. Despite this ticking clock, the core methodology of the project is being heavily studied for global expansion. The specific combination of deep drilling, precise drip irrigation, and heat-tolerant biological clones provides a functional blueprint. Engineers are currently exploring how to transfer this exact model to combat expanding desertification in regions like the Sahara in North Africa or the rapidly drying zones of Arizona. By utilizing date palms as biological anchors, they can establish massive green barriers to block migrating sand dunes and protect vulnerable inland cities. The ultimate technical lesson here is profound. Human engineering cannot change the climate of a hyper-arid desert through brute force alone. The extreme success of this agricultural empire is derived from the perfect integration of absolute mechanical precision and the relentless biological endurance of an ancient plant species. Trading a non-renewable fossil water supply for immense financial profit and food security today is a massive gamble. Do you consider this a stroke of engineering genius or a looming ecological disaster waiting to detonate? Leave your technical perspective in the comments below. Remember to like this video and subscribe to the channel as we continue to break down the most extreme and impossible agricultural projects on the planet. Thank you for watching.